All right, guys, so 5.6 today, we are simplifying complex fractions. So we need to write down the steps first. First step, we are going to multiply the numerator and denominator by the LCD, our new favorite thing. And then we're going to be able to reduce to get rid of the fractions. After you are done multiplying and getting rid of the fractions, you want to combine like terms if possible. And that's our second favorite thing, right?
Yeah.
Or is it our first favorite thing?
First favorite. First.
Okay, our first favorite thing. And then we want to simplify.
Simplify is my favorite.
So we have example 1, x over 2 minus 1 all over 1/2 minus 1 over x. Does anybody see why these are called complex fractions now?
Yeah.
It looks really complex, huh? So, what is in here that we don't really like? I know that I've told you before that fractions are our friends. Does fractions look like our friends today?
No.
No, not so much. So we need to get rid of it. And step 1 tells us to multiply by the LCD. Turn to your neighbor right now and tell them what the LCD is. That means you are looking at every single denominator that we have. Okay, everybody together so that we can hear you. What is the LCD? That was weak. Savannah's the only one that knew, apparently. What is the LCD? Thank you. Okay, so what I want you to do, multiply everything by the LCD. So every single thing is getting multiplied by 2x. Similar to what we did yesterday, right?
But there's no equal.
That's okay. Because we're multiplying the top and the bottom by the same thing, it all reduces to 1, so it's okay. Take a look now at what we have. I have 2x times x over 2. Does anything reduce there? The 2's. The x stays. The 1 and the 2x, so we're still looking at the numerator. Does anything reduce there? No. So look now at the denominator. I have 2x and 1/2. What reduces there? The 2's again, so cross those out. And then I have x, 1 over x and 2x. What reduces there? X. So cross those out. After I canceled out what I could, I multiplied what's left over. So in the numerator, I have x times x. What does that give me, guys? X squared. So all of this is equal to x squared.
She's not looking.
What's minus 1 times 2x gives me?
Don't touch my hair if you're going to get
Negative 2x or minus 2x. Okay, now look at the denominator. X times 1, what does that give me? X. Minus 2. Good. Okay, do you think we are done? No. No. This is, I was grading your quizzes this morning, and on quiz 1, I saw a lot of you that would just stop here. We can still factor. There's still more to do. So, how does the numerator factor? Genevieve. It has a GCF of x. So everybody pull out that GCF of x. What would that leave me with? X minus 2. All over. Oh my gosh.
What?
All over x minus 2. Oh my gosh. What's going to happen, Amara? What cancels? X squared. X minus 2 and x minus 2. So what is my answer? X. So your answer is x. This is not x equals x. This is just simplifying. So we are not solving this time. So your answer is x. Yes, it can. Okay, example 2. We have 3 over x squared. All over 9 over x. Minus 3 over x squared. Marcus said, Miss Smith, I know the answer. 3 over x squared and 3 over x squared cancel. Can I do that? No, Aaliyah, why? Yes, look at that denominator. They are stuck together with that negative sign or that minus. What do minus and plus do? They stick everything together like what, Julian?
Glue.
Like glue. Okay? So we can't do that. So we have to do the exact same steps that we did in the previous problem. So going to our steps, if you need to, take a look at it. Step 1 said what? Zach, will you pull a stick for me? Okay, step 1 said what, Zach?
11.
Who's 11?
My birthday's on May 11th.
Me too.
Oh, Angel, what does step 1 say? Guys. Angel, I'm sorry. What did step 1 say? Yeah, go ahead and read it.
Multiply the numerator and denominator by LCD.
Exactly. Multiply, just throw it up there. Multiply the numerator and denominator by the LCD. Please turn to your neighbor right now. Tell them what the LCD is. Okay, ladies and gentlemen. Wait, can everybody tell me all at once? What is the LCD? Thank you. So will you please multiply everything by x squared? Oops. Okay, so multiply everything by x squared. So now in the numerator, we're going to start canceling some stuff. What cancels in the numerator? Good, x squared and x squared. Samantha, am I blocking you?
Oh, no.
Okay. So x squared and x squared. All of that cancels. What cancels in the denominator on the left? X. Okay, look at that denominator. It's just an x. So how many x's cancel?
1.
Just one. So this is no longer an x squared. It's just an x, right?
Yeah.
Okay, what about the second part? 3 over x squared
X squared.
times x squared. The x squareds cancel. So will you guys right now on your own, will you please write out what we have left over? What do I have left in the numerator? Who? Jasmine left. Who's 39? Celia, what do I have left in the numerator? 3, just a 3. Do you guys agree? Yes. What is in my denominator? I want the whole denominator. Who is 13?
It's you.
Oh, Genevieve. Who's what's left? X minus 3? Okay, time out. What is it? 9x minus 3. Do you guys agree or disagree? Agree. Good. Okay. So my next step then, does it look like I am finished? No. What can I do in the denominator? Nobody's in 41. Zach, will you put me another stick? Nobody's in that seat. 8. Who's 8? Alexia, what can I do next? I can factor out the GCF. What is the GCF, Alexia? What is the GCF? 3. So we have a 3 in the numerator over 3 times. Ladies and gentlemen, if I factor out a 3, what does 9x become? 3x. Minus, if I factor out a 3, what does 3 become? A 1. Good. Okay. Ooh. Okay, guys, what does it look like I can do? Hold on, Zach's going to pull another stick. 15. Aaron. What happens next? Look at what we have. We have 3 over 3 times 3x minus 1. Does anything reduce there? The 3's, good. So those 3's reduce. Okay, guys. Now remember, if it's in the denominator, it has to stay in the denominator. So what is the placeholder in the numerator? A 1. Thank you. All over, what's left in the denominator? 3x minus 1. And that's your answer. All right, guys, so for me it's example 3. For you it's example 5. We have x over 2 all over 5x squared over 6 plus 2x squared over 3. First thing I have to do is multiply by the LCD. Look at my denominators, 2, 6, and 3. What would the LCD be there? Turn to your neighbor and tell them what it is. Just the denominators. Everybody? 6. So multiply everything by 6 only. Okay, so I am multiplying everything by 6. So I can start canceling. Now, looking at my denominators, I have 2 and 6. How do those reduce? Amara?
2 turns into 1, 6 turns into 3.
2 turns into a 1 and 6 turns into a 3. Okay. 6 and 6, how do those reduce? Tiffany? 6 and 6. What? 6 and 6. Yeah. Perfect. Oh, you did both. 6 and 6 comes out to 1. 6 and 3 reduces to 2. So then we need to multiply what is left over. So everybody take a look here. If I have a 3 and an x, what's left over there? Thank you, 3x. Look at the denominator. We have a 1 times a 5x squared, so that's just going to leave me with 5x squared. Plus 2x squared times 2, what's that going to give me?
4x squared.
Thank you, 4x squared. Okay, guys, our simplifying is going to be a little different than the previous two problems because take a look at this. We have 3x all over 5x squared plus 4x squared. Take a look at that denominator. Okay, Carla made a good point. Aren't those x squareds a GCF? Yeah, they could be a GCF, but take a look at it, guys. If I have 5x squared plus 4x squared, can I combine those like terms? Yes. So that's going to give me 3x all over 9x squared. All I did was add 5x squared and 4x squared. Okay. A couple of you are seeing it. That we are not done yet. We can still do some reducing. Take a look at the 3 and the 9. 3 and 9 both reduce, right? Yeah, by what? 3. By 3. So 3 goes into 3 once, and 3 goes into 9 3 times. So I have a 1 up here. Then I have x over x squared. Do those reduce at all? Yes, they do. How many x's reduce there? 1. That x reduces, and the x squared becomes? An x. So what am I left with?
1 over 3x.
Oh, perfect. 1 over 3x. Remember, you have to include the 1 in the numerator. Whatever's left in the denominator stays in the denominator. Okay? All right, last example. Okay, example 4. For you guys, it would be 6. X squared over 10 minus 4 over 10. All of that over x over 5 minus 2 over 5. First thing we need to do is find an LCD. What would my LCD be? Turn to your neighbor, tell them what it is.
Isn't that right?
Okay, guys. So, what is my LCD? Who is 24? Mary, what's the LCD?
10.
10. Good. So will everybody in your notes please multiply everything by 10? So we are multiplying everything by 10 this time. Okay, guys, take a look. Start canceling what you can. In the numerator, 10s cancel. And what else? The other 10s. Look in the denominator now. Both of my denominators there are what? 5. So 5 and 10 reduces to?
2.
2. And this one the same thing, right?
Yes.
So all of that reduces to 2. Okay, so we are going to multiply what is left over. If the 10's totally canceled or reduced, what is left over in the numerator? Zach, will you pull a stick for me? What is left in the numerator? Jocelyn, what's left? I started it.
2.
We're looking at the numerator.
X squared. 4.
What's the symbol with 4?
Oh, negative.
Minus 4. X squared minus 4. Okay. Zach, will you pull another stick? What is the denominator? Give him a second.
It's 40.
Nobody's in 40.
20.
20. Kyle, what is the denominator? 2x minus what? Good, minus 4. Is that what you guys got?
Yes.
Thumbs up if you're this way, far so far. Everybody who's not this far. Okay. All right. Next step is what? Zach, can you pull another stick for me? What is my next step?
31.
31. Skylar, what's my next step? Okay, I need to reduce. Before I can reduce, what do I have to do? Yes, factor. So, ladies and gentlemen, using our factoring methods in the numerator, what method would I use? Turn to your neighbor. Tell them what method. What method will I use to factor the numerator?
34.
34. Samantha, what is it?
I'm sorry.
What factoring method is in the numerator? Perfect. Difference of two squares. So everybody factor using difference of two squares. So that's x plus 2 times x minus 2 all over. Okay. Turn to your neighbor. Tell them what factoring method I'm going to use in the denominator. I think I'm hearing everybody. So on the count of 3, will everybody tell me what method? 1, 2, 3. GCF. Perfect. What is the GCF? 1, 2, 3. 2. That was weak. Okay, so factor out of 2. So that's going to leave me with x minus 2. Chewy. Okay. All right, guys. What can I do next? Zach, we pull a stick.
35.
35. Marcus, what's my next step? What cancels? X minus 2 and x minus 2. Ladies and gentlemen, can I do this?
No.
Why? Who can raise their hand and tell me? Who can raise your hand? Amara, thank you for raising your hand. Why not? Because they're not the same. Why are they not the same? Yeah, in the numerator, guys, those two, that 2 and that x are stuck together, so we can't do that. But we can cancel the x minus 2's. So after I cancel out the x minus 2's, the numerator is x plus 2. All of that is over 2. And that's your answer.
How are we just not working that problem?